Good morning, dear students. Yes. So in the last class, right? So we have discussed about the order of reaction and molecularity of reaction. Then we have seen some of the problems. Okay. Then we have seen the differences also. What is order of reaction and what is the difference between molecularity of reactions? Right. Then we had started with zero order reaction. So what do you mean by zero order reaction, students? Yes. What do you mean by zero order reaction? So what is zero order reaction? The reaction in which the rate of the reaction is right proportional to the zero power of concentration of reactants, right? It is called as what? It is called as a zero order reaction, right? So a reaction in which the rate of reaction is proportional to the zero power. Okay, so the concentration is raised to zero power of the concentration of a reactant, then it is called as a zero order reaction. Or what? A reaction in which the rate of reaction is independent of concentration of a reactant. So it is not dependent, it is independent of the concentration of reactant. Such it is called as order of reaction. Then we have seen the graph of concentration rate versus concentration. So you can represent this graph as y is equals to c, right? So you compare this straight line with the equation y is equals to c. So how the rate is given as minus d of concentration of r by dt. That is, you know that rate is so the concentration of this reactant is raised to the power of zero, right? So this is given as zero order. So this is the zero order. So this is the graph which represents that. Okay. Okay. So, so today we will see the expression. Okay. So very important how to write the expression for rate constant or integrated rate law for your zero order reaction. Okay. Very important. So it is asked for 3 marks. Okay. It can be the question like this. Derive the integrated rate equation for zero order reaction. Okay. So like this, the question is asked. So what you have to write. So it starts like this. So please note this down. Okay, so we are solving integrated rate equation. Okay, integrated rate equation for zero order reaction. For zero order reaction. Okay, so consider a reaction. So what you do? So I'll just divide this into two. Okay. Hmm. So consider a zero order reaction. Okay, so let us consider a zero order equation. Okay, let us consider a zero order reaction. So we know that reactants will give you product, right? Are giving you products. So what is rate of zero order reaction? How it is given as minus d concentration of R by dt, or it is represented by, so K is what? It is the rate constant, okay, into concentration of R raised to zero. So this is our zero order reaction. So by definition, we know by definition that what is the definition? That the reaction here, okay, the rate of reaction is proportional to the zero power of concentration of the reactant. Okay. So now what we are going to do, just we will solve this. So that is, okay. So what we will do, so 10, this, so R is to 0 is 0. So it is minus dr by dt, okay, is equals to K. So R raised to 0 is what? It is 0, right? R raised to 0, the concentration is 0. So we are going to do what? So we are So we are solving. So that is minus dr by dt is equals to k. Okay. Or it can also be written as how? So minus dr. So I can shift this side. So minus dr, that is d of r is equals to k dt. Right? Can we do this? Is it clear up to here? Yes. Okay. So now next is what? So next step is that we are going to integrate the equation. Now you know how to integrate, right? So integrating on both the side. So let us integrate. So next step is what? Integrating on both the sides. So let us integrate on both the sides. So how do you integrate? So integrate the minus dr is equals to integration of k by dt. Okay. So after integration, what you will get? So integration of minus dr is r. Okay, minus r is equals to integration of k dt is k into t. Okay, plus we are introducing a constant, that is integration constant. So this is our first equation. Is it clear up to here? Is it clear
Yes,
up to
ma'am.
here? Yes. So how the marks are given? So up to here you will get 1 mark. Okay, so stepwise, so this is a 3 mark question. So up to here, you will get 1 mark. Okay, so properly writing up to here. Then finding the, now you have to find the value of I. Now I is what here? What is the I? I is our, I is what? I is the constant of integration. Okay, I is constant of integration. Right, I is constant of integration. So how you can find its value? Its value can be found out by obtaining or considering the initial conditions. Okay, so what we can consider that? We can consider, so at t is equals to 0. Okay, if we consider the conditions, so we have to find the value of I now. So how do we find the value of I? So at t is equals to 0, okay. So R will be equal to R naught. R will be equal to what? R naught. So this is that is the initial conditions, okay. So the value of I, it can be obtained by considering the initial conditions. That is at t is equals to 0. So you have to put this condition. So at time is equals to 0 and at concentration of R is equals to R naught. That is your initial concentration. So let us substitute these values in equation 1. Okay, let us substitute these values in what? So this is not equation 1. Okay, I have told you about marks here. So let us put the value in equation 1. So what will be the value? Yes, minus R naught, minus R naught. Okay, just a second. Hmm. Okay, minus R naught is equals to K. Okay, K into T is equals to 0. Okay, so how much you are getting? Plus I, right? So K into 0 will be 0. So minus R naught is equals to I. So this is the value of your integration constant. Got it? Okay, now what we have to do? We will substitute this in equation I. Okay, that is 1. So let us substitute the value, substitute the value of I in equation 1. In equation 1. Okay, so what will be the, let us see now. So minus R is equals to K T plus R naught. Okay, so we have got the value of I. So that value of I we have put here. So that is okay. So if I shift this what? Minus side on the right hand side. So what it will be? R is equals to minus KT plus R naught. Okay, so this will be my equation number 2. Okay, so let us rearrange the equation 2. So rearranging equation 2, we get what we get? We get what we'll get. So K is equals to R naught minus R by T. So we have to find the rate constant of zero order, right? So this is the expression for K for zero order reaction. Okay, so up to here you will get 1 mark. Okay, up to this equation you will get 1 mark. Up to here you will get 2 mark, and up to here you will get the 3 marks. So if you do any mistakes in these steps, okay, so like that the marks will be deducted. Suppose if you have done some mistake here, so only you will get 1 mark. Okay, for the entire question. Okay, if you have done the mistake in the first step only, so you will get 0 marks like that. Okay, so the marks are distributed like this. Got it? Is it clear? So let me explain you one more. So one more time. So 1 mark, here 2 marks. This is marks. Okay, and this will be the third mark like that. So one mark each, or don't, or I'll write one only here. Okay, don't get confused. So here 1 mark, here 1 mark, and here 1 mark. Okay. So up to here, if you write, so it will be 1 mark, considered as 1 mark like that. Okay, so let us revise it once more. So what is the integrated rate equation for zero order reaction? So according to definition, we know that the rate of the reaction is proportional to the zero power of concentration of the reactant. So if you consider a zero order reaction, so reactants will react to give you the product. So rate is equals to minus dr by dt is equals to, okay, K into R naught, right? And that is your reactant. The power is raised to 0. So this is according to the zero order reaction. So that is minus dr by dt is equals to K, because K R raised to 0 is 0 only, right? So so what we'll do now, after rearranging, what we are doing, we are shifting this dt on the other side. So what we get, minus dr is equals to K dt. Okay, so what is the next step? We are integrating this on the both the sides. So we are doing integration on the both the side of this equation. So what we get, integrated of minus dr is equals to integration of K into dt. So after integrating, what we will get? Minus R, concentration of R is equals to K T plus I. Okay, I is what? I is the constant of integration. So we have to find the value of I. So how we can find the value of I? By putting the initial values, okay, at initial concentration or initial conditions. Okay, so what is the initial conditions? The conditions are at T is equals to 0, R will be equal to R naught. That is your initial concentration. So after putting this values in the equation 1, okay, so we are substituting this in equation 1. So I'll write it here. Okay, don't get confused. So I'll write, substitute the at is equals to 1. Okay, this is equals to equal to substituting in equation 1. Okay, so after substituting in equation 1, we get minus R naught is equals to, okay, K into 0 is 0 plus I. So I is equals to minus R naught. Okay, now this value of I, we are going to again substitute in equation number 1. So substitute the value of I in equation 1. What we get? Minus dr by, okay, minus R is equals to KT plus R naught. So what we are doing here, we are shifting this negative side on the other side. Okay, so R, concentration of R is equals to minus KT plus R naught. So if we rearrange this equation, what we'll get? So if we take K on the left hand side, so R naught, this will go on the left hand side. So that will be minus R upon T. So this is the integrated rate law expression for zero order reaction. Is it clear? Yes, very important. Asked for 3 marks. Is it clear? I hope you have noted down. Yes, and if you're noting it down, so please write it properly. Don't miss the negative sign. and all things. Okay, so it is very important. So don't write in hurry burry. I'll wait for you. Okay, so you write it properly. So got it? Okay. So this is the integrated rate law expression for zero order. Okay, this is the integrated rate law expression for zero order. Got it up to here? Yes? Okay. Shall I clear this? Now, we saw in the last class, okay, we have seen the graph of rate versus your concentration, where you can see a straight line which is equal to y is equals to c, right? So we had seen like this. So rate versus concentration. Right. So this is assembling y is equals to c. Now from the equation 2, from this equation 2, okay, we will get so we are plotting another graph. So let us plot another graph. Okay. So there is one more graph where we are taking, so it is a graph of concentration, okay, versus time, concentration of reactant versus time. So this is a straight line. Okay, it is a straight line and it is in the form of y is equals to mx plus c. It is in the form of y is equals to mx plus c. So the concentration of R versus time, it is a straight line. So it is a straight line with a slope of minus k. Okay, the slope is minus k. Slope is minus k. Okay, and the intercept is r naught. So here the intercept is your r naught. R naught. So this is another graph. Okay, so another graph where we can see the concentration of R versus time graph, where it is a straight line which is following y is equals to mx plus c, and the slope is minus k. Okay, so we are writing the we have drawn the this what graph for from this particular equation. Okay, second equation. So you know, so minus k is your this, okay, t, and your intercept is your r naught. Okay, got it? So this is your integrated rate law equation for zero order reaction. Is it clear up to here?
Yes, ma'am.
Okay. So let me clear this. I hope everyone has taken it down. Right. So if the concentration of the reactant at initial condition is a mole per liter, suppose, okay, if the concentration of a reactant, okay, if a concentration of a reactant at initial concentration, okay, at initial concentration is one a mole per liter, and at a time of t, at a time of t, okay, and x moles of reactants, x moles of reactants changed into product, okay, changed into product. So how will be the concentration? Therefore, concentration of reactant remained at time t is, so what will be the concentration of the reactant at time t? It will be A minus X mole per liter. Okay, it will be A minus X mole per liter. So if we consider the concentration of a reactant, okay, if we consider a concentration of the reactant at initial concentration, which is equal to A mole per liter at a time t, at a time t. So X moles of reactants change into product. So concentration of the reactant remained at time t will be A minus X mole per liter. So suppose that is your R naught. Okay. Your initial concentration is what? Your initial concentration is A, and after time, this R will be equal to A minus X. Okay. So initial concentration is A, and after the time t, it is changed to A minus X. So K will be given as what? K will be given as, what was K? K is equals to R naught minus R by T. So if we substitute here, so R naught is what? A, okay, and R is A minus X, okay, by T. So that is equal to A minus A. This, so it is K is equals to X by T, okay, or X is equals to K into T. Got it? So this is at so for zero order reaction, the amount of product formed, it depends upon time, okay, taken by the reaction. So whatever the amount of product is formed, okay, at the time t, so it depends on what? It depends on the time, okay. So therefore, zero order reaction. So from this equation, what you can see that zero order reaction, okay, for zero order reaction, the amount of product formed, the amount of product formed depends on what? It depends only on time taken by the reaction. Okay, by time taken by the reaction. So this is about your zero order reaction. Okay, so remember this. So at initial concentration, okay, if we consider any concentration of a reactant at initial concentration A mole per liter. So after some time, so this is your initial concentration, okay, of a reactant. So after a time, so suppose the time is T. So what will happen? Some amount of, that is X moles of reactants is changed into product. So therefore, how we are calculating the concentration of the reactant? Okay, after the time t is what? A minus X. So initial minus how much it is, the reactants is consumed, okay, into product. So A minus X mole per liter. So what is your R naught? R naught is your initial concentration. This represents your initial concentration. So your initial concentration is A, and at time t, after time t, what it is? A minus X. So some of your reactants is turned into, or it is changed into products. So it is A minus X. So we know that, what we know, since we know that K is equals to R naught minus R by T. So therefore, after substituting, what will get? A minus, so we are substituting these value here, right? So it is A minus A of X. So A plus A and this is minus A get cancelled. So it is X. So K is equals to X by T. X is equals to K by T. So for zero order reaction, how much the amount of your product is formed, it is depending on this temperature. Sorry, it is depending on the time. Okay, small t is nothing but your time. Is it clear? Yes?
Yes, ma'am.
Yes. What about others?
Yes, ma'am.
Okay. Fine. So this was about zero order reaction. So this is a very important reaction. Okay. So now next we are going to see is what? Next we are going to see is the first order reaction. Okay. Next we are going to see is the first order reaction. Okay. Better I will only solve. Okay. So if I solve, then it will be understood well. Okay. Then we will see the this. Okay. So what is the first order reaction? First order reaction. Okay, so a reaction in which rate of the reaction is proportional. Okay, a reaction in which rate of the reaction is is proportional. Okay, this is a proportional sign. to the first power of concentration of reactant. Okay, first power of concentration term of reactant. So this is called as what? So when the concentration term is raised to 1, then it is called as what? It is the first order reaction. Right. So what is the example? Hydrogenation of ethene. Hydrogenation means addition of hydrogen across the double bond. Ethene is what? Ethene is a molecule which has a double bond, right? So we are doing hydrogenation. We are adding hydrogen molecule across the double bond, right? Across the ethene molecule. So how it is? C2H4. Okay, C2H4 plus Ha2. Okay, hydrogen gas. What you'll get? You will get C2H6. Okay, gaseous. So how is the rate? Rate is dependent on the concentration of the reactant, that is C2H4 raised to 1. Right. So this is the rate equation for your hydrogenation of ethene. So here the concentration is raised to the power. Okay, the rate of the reaction is proportional to the first power of the concentration term of the reactant. So please remember the examples, very important. In case of zero order reaction, which was the examples we have seen? We have seen the decomposition of ammonia, right? Please remember that we have seen the decomposition of ammonia. In case of first order reaction, what is the example? The example is hydrogenation of ethene. Okay, hydrogenation of ethene. Is it clear? Yes. So the definitions are also important. It can be asked for 2 marks. What is first order reaction? Give an example. What is zero order reaction? Give an example. Okay, like this, the questions can be asked. So whatever the important things I have been told, so please study it thoroughly. So practice the rate, this what? Rate constants for both today. Okay. So zero order also and first order also. Got it? Okay. Okay. So let us see the first order reaction. Okay. So let us find out the expression. Okay. So let me write here expression for rate constant. Okay. Or it is called as the integrated rate equation for first order reaction. Okay, I'm writing shortcut. Please don't write shortcuts. Equation you write completely, reaction you write completely. So don't use shortcuts in your paper. Okay, fine. So expression for rate constant. So the question can be derived the rate constant equation for first order reaction. Okay, or give an expression for rate constant. Like this, the question is asked. Okay, so consider consider a first order reaction. So like this, it should start. Okay, how I'm writing the same, you should follow. Okay, so how I am writing the same, you should follow. Okay, so you should not you should not skip any steps here. Okay, so consider a first order reaction. So first order reaction, reactants giving you products. Okay, so according to the first order reaction, what is rate? Rate is equals to minus dr by dt. That is, rate is equals to concentration of R raised to the first power of term. Okay, so the power is raised to 1 here. So what we are doing? We are doing the R term separately. What we will do? We will separate the terms. Okay, what we will separate? Whatever the R terms are there, that we will take on the one side. Okay. So what is the equation now? So rate is equals to, so let us separate. So separating separating the variables. Okay, so we will take the variables of same on the other side. So it is minus dr by, okay, minus dr by. So what I'll do, I'll shift here. So it will become r. Okay, raised to 1 is, if you don't write 1 also, it is understood, it is 1. Okay, so is equals to k into dt. So this dt I have transferred on the other side. So this is the equation we are going to get. So separating the variables, we are separating the variables. So RR on other one side, and your this what? So this is K. Sorry, this is K. So K on the other K dt. So we are transferring this dt on the other side. Okay, like this. Now what is the next step? We are integrating the equation. So integrating. Let me write it here. We have less space. So integrating on both side. So let us integrate on both side. What we are going to get? Yes, integration of minus dr by dt is equals to integration of k into dt. So what we are going to get? Yes, what will be the expression? What I am going to get? Minus ln of r. Okay, minus ln of r is equals to k t k into t plus I. Right. So this is the equation 1. So minus dr by dt is what? Ln of r, concentration of r. Okay. So we are going to get what? So this is the equation number 1. Now what is I? I is integrated constant. It is a integration constant. Okay. It is a or constant of integration. I is integration or right constant of integration. Integration constant. Okay. Now what is the next step? Yes. Now let us put the initial values, initial condition. Okay. Let us put the initial condition where t is equals to 0 and r is equal to r naught. So this is the initial conditions where t is equals to 0. Okay. At initial conditions. So if we put the initial condition, that is t is equals to 0 and r is equals to r naught, we are going to get the value of I. We have to find the value of I, that is your integration constant. Now put this values in equation 1. Okay, put in equation 1 these values. Okay, so after putting this in equation 1, what you'll get? Minus ln of r naught is equals to k into 0 is 0. So it is, I'll write directly, it is I. So I is equals to minus ln of r naught. Okay, so this is the value of I. So what we are doing again, substituting value of I in equation 1. Yes, what I'm going to get? I'm going to get, okay, this, in this I'm going to put the values. Okay, there is a negative sign. Don't miss that negative sign. So this is the, so what it is? Minus ln of R is equals to k t plus ln of, sorry, it is minus, no there. So plus of minus will be minus. So it is minus r naught. Okay, got it up to here? Yes. Let me clear above. Okay. Now, so we have got minus ln of r. Ln of r is equals to kt minus ln of r naught. Right. So what I'll do, I'll take minus common. Okay, I'll take minus common. So that is ln of r is equals to, so I'll shift this minus this side, so it will be minus kt. So this will become plus ln of r naught. Okay, so this is our equation 2. This is our equation 2. So let us rewrite this equation. So rewriting equation 2. So let us write the equation 2, rewrite the equation 2 as, so it is kt. Okay, kt is equals to, so if I take kt here, so it will be ln of r naught minus ln of r, okay, upon ln of r, or I'll write it. So this is like this. So kt is equals to ln of r naught minus ln of r. So kt, what is ln of, so ln is common. So let me take, so it is ln of r naught minus r is r naught divided by r. Right. So if I take ln common, so ln of r naught minus ln of r can be written as like this also. So that is okay. Kt is equals to, so the value of ln is 2.303 log of r naught by r. Okay, so the okay, what is the value of ln? Ln is 2.303 log of 10. Okay, so this is the value of ln. So substituting the value of ln here, we get kt is equals to 2.303 log of r naught by r. So therefore, k is equals to 2.303 log of r naught by r, okay, divided by your kt. Got it? So this is the equation for first order reaction, rate equation for first order. So this is the expression for first order. Is it clear? Yes.
Yes, ma'am.
Oh, yes. What about others? Okay. So let me explain it once more. Okay. So very important. This is very important. So let us take it in the one page only. Let us complete it in the one page. I'll write it properly. So it will be a revision for you. So today itself, what you have to do? You have to practice both this rate law expression. Okay. I want you all to write both the rate law expression. You have to practice these both. Okay, today itself, zero order and first order, because any one of the question can be asked for 3 marks. Okay, so integrated rate equation, integrated rate equation for first order reaction. Okay, so let me start. Okay, so what is the steps? So consider the first reaction. Consider, I'll not write this anything. Okay, so consider the first order reaction, that is reactants giving you products. So that is rate is equals to minus dr by dt. Okay, is equals to, it can be, so if you write, this is a rate constant, that is r is to 1. So this is with respect to the first order definition, that is rate of the reaction is proportional to the first power of the concentration term of the reactant. So let us separate the variables. So separating the variables. So let us separate the variables. So after separating the variables, what I'll get? Minus dr by r, okay, is equals to k into dt. Okay, k into dt. Now what we are, next step is what? Integration. So after you get this, you have to integrating on both the sides. So you have to integrate on both the sides. So how you are going to get? So integration of minus dr by r is equals to k into dt. So what we are going to get after integration, this is removed, minus ln of r, okay, is equals to k into t plus I. So this is our equation 1. This is our equation 1, where I is the constant of integration. I is the constant of integration. Okay. So what we are going to get, we are going to put the initial conditions. What is the condition? So if you want to find the value of I, we have to put the initial conditions. Okay, the initial conditions, that is at t is equals to 0, r will be equal to r naught. Okay, so this is the initial condition. So what will be a equation 1? So equation 1 becomes, what will be equation 1? Minus ln of r naught is equals to I. So this is your equation 1. Okay, now substituting the value of, substituting value of I in equation 1. So what we are going to get? This is the equation 1 here. Okay, so let me mark it with another color. It will be highlighted. Okay, so this is your equation 1. So what I'm going to do, I'm going to put the value here. So minus ln of r is equals to k t minus ln of r naught. Okay, now common, take the minus sign outside. So ln of r is equals to minus kt plus ln of r naught. So what we are going to do? Now we are going to rewrite this. Okay, rewriting. So this is your equation number 2. This is your equation number 2. So let us mark it. So please highlight it in the exams. Okay. Not with the highlighter, with your pencil. Okay. In the exams, you are only supposed to use uh, blue pen and pencil. Okay. Don't use black pen, green pen, anything. So you can use only pencil. So you can highlight this with the pencil. So using pencil, you can put a box. So ln of r is equals to minus kt by kt plus ln of r naught. So this is your equation 2. So rewriting equation 2, okay, how we are going to get? So kt is equals to ln of r naught minus ln of r. Okay, ln of r naught minus ln of r. So right, okay. So now what it is? Kt is equals to, okay, kt is equals to ln r naught by r. Okay, so this is the this according to, so ln of r naught minus ln of r will be ln of r naught by r. Okay, so therefore, so that is kt is equals to, what is the value of ln? So ln is equals to 2.303 log of 10. So putting this value, it will be 2.303 log of 10 to the power r naught by r. Okay, so k is equals to k, therefore k is equals to 2.303 log of r naught by r by t. So this is our first order equation. Okay, is it clear? So this is a, so equation. So this is your first order reaction. Is it clear up to here? Yes. So both
Yes,
the
ma'am.
for both the laws are clear. So these are very important integrated rate law equations. Okay. So this will be asked for exam. So everyone should practice this. So I've explained both the reaction 2 times. If you want again me to explain, I'll explain. Okay, no problem. So both the zero order and first order reaction. So it is very important. So stepwise you have to write. So again here, so up to here, you will get 1 mark. Up to here, you will get another mark. And for this last proper equation, 1 mark. Okay. So till here, all the steps are correct, you will get 1 mark. So till here, if you write all the steps correct, one more mark. If you write the steps correct till here, then you will get 3 marks, complete 3 marks for your exam. Is it clear? Okay. So let us go for the next one. Zero order. So this is first order. First order is clear. Yes. Okay. First, let me. Okay. So first we'll see that zero order only then. Okay. Fine. So zero order reaction. Okay, if we see the zero order reaction, one more time we'll just glance and then we'll move forward. Okay, whoever has doubts, you can just go through. Okay, so considering a zero order reaction, we know that reactants giving you product. So rate is given as what? Minus dr by dt. Okay, so that is concentration of that is rate constant. Rate constant is equal to concentration of R naught. Right? It is R naught. Fine. So here that is so minus dr by dt into k, because r naught value will be 1. Okay, r raised to 0 will be 1. So now this is the equation. What we will do, minus dr by is equals to k into dt. Okay, so I'm shifting this here. So what next step is what? Integrating. So integrating on both sides, integrating on both the sides, what we are going to get? Integration of minus dr is equals to integration of k dt. So what we are going to get? Integration of minus dr is minus r is equals to integration of k dt is k, integration of k is k only, and dt is t plus I. Okay, what is I? I is the, so this is your equation number 1. So let me highlight it with some other color. So this is the integration 1. So I is what? I is constant of integration. I is constant of integration. So what are the initial conditions? The initial conditions are initial conditions. So at initial conditions, t is equals to 0, r will be equal to r naught. Okay. So what we'll do, we'll substituting in equation 1. So substituting in equation 1, we get what we get. So we will get a minus r naught is equals to k into t is 0. So it will be 0. So the term will be, so I is equals to r naught. So put the value again, substitute the value, substitute the value of I in equation 1. So what we are going to get? Minus r is equals to k into t plus, sorry, minus r naught. Okay, so this is your, after substituting the value of I. Okay, now that is, so we'll take this minus inside. So it will be r equals to minus kt plus r naught. So this is your equation number 2. Okay, this is your equation number 2. So let me highlight it. So this is your equation number 2. Now, so that is, okay. So let us rearrange it. So rearranging equation 2, we get what we get after rearranging kt. I'll take here. So it will be r naught minus r. So I'm shifting this side, right? So it will be k is equals to r naught minus r by t. Got it? So this is my equation number. This is my this zero order reaction. So if you write this much also, okay, you will get marks, but you have to write properly. Is it clear? Is it clear? So both zero order and first order you have to practice today. Okay, write it 2-3 times. Okay, you will understand. So if you write the steps, write it. So see, first see and write. Okay, one time, two time, and then you practice without seeing. It will be clear. Okay, so for first order reaction, what was the equation we got? For first order reaction, we got the equation as k is equals to 2.303 by t log of r naught by r. And for zero order, k is equals to r naught minus r upon t. Okay, so this is the for zero order reaction, and this is for first order reaction. Okay. Then, so here in this equation 2, okay, what was the equation 2? Ln of R minus KT plus ln of R naught. So this was the equation 2 in the first order reaction. So by taking the equation 2, so this will represent a straight line. Okay, this represents a straight line where we are plotting a graph of ln of R versus time. Okay, ln of R versus time, where you have a straight line. Okay, where you have a straight line and your slope is minus k. Your slope is minus k. Okay, so ln of R and your intercept is ln of R naught. Ln of R naught. So this is your this what? So your intercept is ln of R naught. So this is your graph. Okay, this is your graph. Okay, here we are plotting the graph of equation 2. Okay, so this equation, it represents your straight line. Okay, so we are drawing a graph of ln of R versus time t. And this is a straight line. Okay, and the slope is minus k, and the intercept is ln of R naught. Okay, then equation 3. So this is the equation 3. So this equation 3, how it can be written as? It can be also written as ln of, that is log of R naught by R is equals to K, okay, divided by 2.303 into T. So this is the equation can also be written as like this. So this represents a straight line. Okay, this will represent your equation. So if I plot a graph here, so of log of R naught by R versus time, okay, of from this particular equation. So what I'm going to get? I'm going to get a straight line. Okay, I'm going to get a straight line and the slope is k upon 2.303. Okay, so this is the graph. Okay, so what happens? So here the equation 3, it can be written like this. And if you draw a graph, so this will represent a straight line. So a graph of log of R naught by R versus time. Okay, it is a straight line with the slope of k by 2.3, and it passes through the origin. So this equation 3, if we write like this, so you will get another graph and this straight line will pass through the origin. Okay, so we have seen two graphs. So from ln of from the equation to one graph, okay, which represents a straight line which has a slope and a intercept. Okay, and we have seen another this. So if we take the last equation, third equation. So after rearranging the equation, okay, we are going to get this particular graph. Okay. So another condition. So this was the first condition. This is the first, then second, and one more. So suppose the initial concentration. Okay, if the initial concentration of reactant, okay, if the initial concentration of reactant is A mole per liter and X mole of reactant, X mole of reactant gets changed into product at time t therefore concentration of reactant remained at time t is A minus X mole per liter. So we know that R naught is your initial concentration and your R is A minus X. So if you put this in the 2.303 by T, okay, log of R naught by R. So if you put in this particular equation, so if you put the values here in this particular equation, what we are going to get? 2.303 by T log of A by A minus X. So this is when you have, okay, when you have initial concentration if of the reactant is A mole per liter and X moles of reactant is getting changed. So your reactants from initial concentration of the reactant is A. Okay, but and X moles of the reactants are getting changed into the product at time T. So T is the time taken. So how much concentration of reactant is remained at the time T? So it will be A minus X. Okay, so A minus X is the after some time T, this much is reacted and the initial is this much. So if you put these values in your first order equation, you're going to get this particular equation. Is it clear? Yes. So the problems based on the first order, we will solve in the next class. Is it clear up to here? So
Yes,
in
ma'am.
today's, yes, in today's class, we have seen the rate laws expression. Okay, that is a rate constant expression for first order and zero order reaction. So in the next class, we will see a problem. Okay, and then we will start with the half-life reaction. Okay, so important half-life reactions, and then we have some problems. So problems are very important from this chapter. Okay, so after solving problem, okay, then we will proceed further. Okay, fine. Any doubts in today's session? Yes, any doubts? Anybody? So there are 7 participants. So any doubts here? Okay, Shri Varuni and Lubna has no doubts. What about others? Any doubts, students? Okay, fine. So I hope it is clear. Yes. Okay. So if you don't, so again, what you can do after this, okay, you can just practice this. Okay. If you did not understand anything, so go through the things, whatever have been told. Okay. The students who have missed the classes can again, okay, you can look back to the previous classes. Okay. They have been stored in YouTube. Okay, you can go through those videos also and you can check with that. If you have not understood anything, okay, any concepts, you can come back to tomorrow. Okay, fine. So I hope there are no doubts. Fine. Okay, fine. So by this, I'll be ending the session here. Okay, we'll meet in tomorrow's class. Yes. Thank you. Thank you, students. Have a good day. Yes.